This is chapter 4-1, Triangles and Angles, lesson part 2. Last time we left off, we were talking about classifying triangles by their angles. Please review part 1. Now we're going to talk about classifying triangles by their sides, not their interior angles, but their side lengths. The first triangle we're going to look at is called an equilateral triangle. Remember, we're classifying by the side lengths. Equilateral triangle means that all three of the sides are the same exact length. Please look at the word equal as in equal, lateral talking about the sides. Okay? And all three sides again are congruent. And when three sides are congruent, to show congruency, they show the marker. We talked about this before. Because they each have one marker, that means that all three sides are the same length. If one of these sides had a 2 and these both had just 1, that means only this side and that side on the triangle are congruent. However, because all three are marked with the same indicator, 1/, that means that all three sides are the same length. Next type of triangle, classifying by sides, is called an isosceles triangle. At least, okay, please make sure you get this, at least 2 of the sides are congruent. So here I have 1, 2 are congruent, and I know they're congruent because they both have that marker there. This could be congruent, but because it doesn't show this one marker here, like that, I cannot say that the third side is congruent. But I know that the first 2 here are congruent. And if you have at least 2 sides of a triangle that are congruent, then that's isosceles. Okay? The third type of triangle, classifying it by sides, is called a scalene triangle. And that's when none of the sides are congruent. All 3 sides are different lengths. Again, this is one side marked by 1. This second side here has 2 markers, and the third has 3 markers there, meaning that all 3 sides are different lengths. So this is called a scalene triangle. If I want to classify a triangle, I classify by 2 ways. I classify first by their angle, then their side. So I do their angle, then the side. So let's classify this triangle here. Okay, triangle ABC. What type of triangle is this? Remember, I want to classify it by the interior angles and then their sides. Remember, we talked about angles on the interior here on the triangle. I have a 58 degree, 65 degree, and a 57 degree on this particular triangle. If I look at the 3 interior angles, I notice that it's small, which means it's acute. I'm classifying it by angle first. And if I do angle first, this is an acute. And I know it's acute because the 3 interior angles are going to be less than 90 degrees. Now looking at the side lengths, if I look at the 3 side lengths, I see here easily that I have 1, then 2 on this side, and 3. That means it's going to be a scalene. None of the side lengths are the same. So how would I name this? This is called an acute scalene triangle. The name of this triangle is acute scalene. I classified it by the interior angles and then its side lengths, acute scalene. Let's try another. I have another triangle here, triangle EFG, and I see 130 degrees, and I see that these 2 side lengths are congruent. Okay, remember we want to classify a triangle by its angle first and its side. If I'm looking at the angle, well, just because immediately I see 130 degrees, I know that this is going to be obtuse. Okay, and then I'm going to do it by side, classify this triangle by side. So I see here clearly that 2 sides are congruent. That means that it's going to be an isosceles. So how do I call this particular triangle? This is an obtuse isosceles triangle. This is an obtuse isosceles triangle. Okay? Now, next section. New information right here on this page here. Triangle ABC. This was the portion of trig or geometry that I really didn't like. You're going to see this over and over again after this class in trigonometry. You must make sure you get this. This is the part that I couldn't stand, and it was very, very easy. Once it was made clear, I was very good. Please listen carefully. You may have to rewind. Make sure you understand this. If I have triangle ABC, and I'm talking about angle C, which I'm going to classify this angle here, then there are a few things that we need to know if I'm talking about angle C. If I look at angle C, I'm referencing angle C, side AB, this side here, AB, in reference to angle C, is called the opposite side or opposite leg, right here. If I'm still talking about angle C, side AC is adjacent. We need to remember that the word adjacent means next to. Side AC is going to be adjacent. If I'm talking about angle C. If I'm talking about angle C still, that means that BC is also next to, so I call that adjacent as well. That's my adjacent leg. That's if I'm talking about angle C. Now, I can switch. I can still talk about this same exact triangle, triangle ABC, and let's say someone else is talking about this triangle, but now they don't want to talk about angle C. They want to talk about angle A. I can switch to angle A, and the opposite leg is different. It matters about which angle am I talking about. If I'm talking about angle A, and I ask which leg is opposite, opposite means across. I'm no longer talking about angle C. I'm looking at angle A. What's across from this angle? Boom, right here. That's BC. Side BC is going to be the opposite leg or opposite side. If I'm talking about, and let me back up just a little bit if you review your notes, when we were talking about angle C, this leg BC was the adjacent leg, but that's because I was talking about angle C, but that's not the case. I'm talking about angle A, and the opposite leg or the across leg is BC. So what is AC in reference to angle A? Leg AC is adjacent or next to angle A. Leg AB is also next to angle A. That's also adjacent in reference to angle A. You can still switch this further, and as I'm erasing this triangle, you should redraw. Okay? I can erase this again and now talk about angle B. I'm still talking about the same triangle, ABC, but now let's say I want to talk about in reference to angle B. If somebody's talking about angle B, the question is, what is the opposite leg from angle B? Opposite means across. Well, BA or AB is next to. So that means AB is adjacent. BC is touching this angle here. BC touches right there. That means that BC is also adjacent to angle B. The leg that's across or opposite is going to be AC. Okay? Remember, listen to the angle somebody calls out to you. Because whatever angle they're referencing, that's how you know what's going to be opposite to it or adjacent. Okay? Now, angles A, B, and C are all vertices. Every triangle has vertices. There are points where two non-collinear points meet. So here we have. Let me erase this here as if it were a new triangle. This here point is a vertex. It connects these two connect as a vertex. I have a vertex here and a vertex there, or vertex. Each one individually is called a vertex. When I have plural, it's called vertices. Vertices. Okay? All right, now I'm talking about triangle ABC for a right triangle. For a right triangle, let's look here. If I'm referencing triangle ABC, which angle is the right angle? And it's angle A because they have that marker, that corner marker. Angle A is the right angle. So this will be a right triangle. Here's the question. Well, which leg is opposite to angle A? And it's going to be BC. It's across from angle A. I'm referencing this angle, so BC is opposite from angle A. If I'm looking at triangle ABC, when we talk about the leg that's opposite to the right angle, only the right angle, only on right triangles only, the leg that's opposite is called the hypotenuse. We don't call it the opposite leg. Only on the right triangle, we call this the hypotenuse. It is opposite, but it's called the hypotenuse. Okay? We don't call it opposite, even though it is, but we call it the hypotenuse. Only on a right triangle, and only the angle that's right. So angle B, let's look at angle B. What's opposite to angle B? CA is opposite. This is called opposite. I don't change this one to hypotenuse. It stays opposite because angle B is not the right angle. It's just a regular angle. It's opposite, it stays opposite. Only on the right angle, this is BC and it's opposite. Because it's across from or opposite to the right angle, I call that hypotenuse instead of opposite. Okay? What are the adjacent legs of angle A? The adjacent legs are BA, or this AB, and AC are both the adjacent legs. Okay? So this is adjacent, BA or AB, and then CA or AC, whichever way you want to call it, are the adjacent legs. Okay? Now let's look at isosceles triangles. Looking at triangle NBA, which legs are opposite? Which legs are opposite if I'm looking at, let's see here. First of all, let's do angle N. If I'm looking at angle N, okay, which leg is opposite? And that's going to be BA. If I'm talking about angle N. Okay? On an isosceles triangle, the opposite leg is called the base. So I don't call this opposite only on an isosceles. Any other triangle, this is called opposite. Okay? But on an isosceles, I see that NB and NA are congruent. The leg that's not congruent is going to be this left out leg. Angle N is the opposite leg. We don't call it opposite, we call it the base. Okay? It's the non-congruent side. The base is the non-congruent side. It's not congruent to the other two legs. Therefore, it's called base instead of the a regular leg. Right? What are the adjacent legs? Okay? NB and NA are the adjacent legs to angle N. Okay? And again, as I stated, on an isosceles, the two adjacent legs are going to be congruent. All right? And this concludes your lesson.